Assalamualaikum. Today we will present about vector and scalar. So the title is engineering. My team members is Nurin Farahia binti Nik Yusaini Amir, Putri Salah Milsa binti Azman, Najma Emma Syazwan bin Kamal Arifin, and Zaim Hilmi bin Ahmad Sharifuddin. What is a vector in engineering? A vector is a mathematical object that has magnitude and direction and satisfies the laws of vector addition. Vectors are used to represent physical quantity that have a magnitude and direction associated with them. For example, the velocity of an object is a vector. The force acting on an object is a vector. Besides, the direction of the vector specifies the line of action of the force, and the magnitude specifies how large the force is. Vector and scalar in engineering. Vectors are used in engineering mechanics to represent quantities that have both a magnitude and a direction. Many engineering quantities, such as force, displacement, velocities, and acceleration, will need to be represented as vectors for analysis. Vector quantities contrast with scalar values such as mass, area, or speed, which have a magnitude but no direction. When dealing with vector in equation, engineers commonly denote something as a vector by putting an arrow over the variable. Variables without an arrow over top of them represent a scalar quantity, or simply the magnitude of that vector's quantity.
Okay, my name is Nurin Farahia. I will talking about vector quantity. To represent a vector quantity, we will generally have two options. These two options are magnitudes and direction form, where the magnitude is given as a single quantity and the direction is given via an angle or combinations of angles. Second is component form, where the magnitudes and directions are given through components magnitudes in each coordinate directions. Next is scalar quantity. In contrast with scalar quantities, we cannot add, subtract, multiply, or divide them by simply adding, subtracting, multiplying, or dividing the magnitudes. The directions will also play a critical role in solving equations that contains vector quantities. Okay, next is scalar. Scalar quantities are those which only a magnitude is associated. Examples of scalar quantities are time, volume, density, speed, energy, and mass. Examples of vector quantities are displacements, velocity, acceleration, force, moments, and momentum. Speed is a scalar. Example of mass is the property of an object pertaining to the strength of its gravity attractions towards other bodies. For example, we can describe the mass of an elephant as 5,000 kilograms. Next one is speed. The average of speeds can be defined as the total distance traveled divided by the total travel time. When you are driving on the interstate, you are likely going at a speed of around 65 miles per hour.
Hi, Assalamualaikum. My name is Putri Salah Milsa binti Azman. My matrix number is 01DKA20F2061. So I'm going to talk about the vector and scalar applications in engineering. In engineering, vectors and scalar can help facilitate constructions that require coordinate readings, such as aircraft and submarine. A navigator is an electronic device used to show directions to something we want to go. In navigation, vectors have a great influence on the location of an observed location from a moving place, such as a vehicle and a light. For example, vectors used for aircraft navigation system. All aircraft is equipped with a navigation system so that the aircraft does not get lost while flying. With the vector system calibrated by the aircraft navigation computer, the pilot can monitor the direction of the aircraft landing even at night. This is the example aircraft navigation system. Application of vector. A roller coaster is an amusement ride developed for amusement parks and modern theme parks. Most of the motion in a roller coaster ride is a response to Earth's gravitational pull. The speed is sufficient for it to climb over the next hill. This process occurs over and over again until all the train's energy was lost to friction. The train of cars slows to a stop. If no energy was lost to friction, the train will be able to keep running as long as no point on the tracks was higher than the first speed. Here, vectors of forces, acceleration, and velocity are important to make a safety system. If designer consider then accurately, then system will be safely.
Assalamualaikum and good evening. My name is Zaim Helmi bin Ahmad Sharifuddin and my registration number is 01DKA20F2064. So I'm going to explain about examples and solutions. First of all, an object has two paragraph forces F equal to 50N and F2 equal to 30N as shown in the diagram below. Second of all, calculate the magnitude resultant force F and determine the angle 0 which makes F the cross axis. As you guys can see in the diagram, the angle located in between F and G. So, in this second slide of mine, I'm going to talk about the parallelogram law, and this calculation is based on our project. First of all, we need to find FG, which means FO plus OG, and the final answer will be negative 4I plus 5J plus K. And the second step is we need to find the GH, and then GH equal to GO plus OH, and the outcome or the final answer will be 2I minus 2J plus 3K. So in this next part, I'm going to explain how to find the angle between two vectors. To find the angle between F and G, if F is 6I minus 2J plus K and G is 2I plus 3J plus 2K. In order to find the angle between two vectors, we need to use the formula, and the formula is cos theta. And the next step, we need to find the FG, which means 6I minus 2J plus K, and then we need to minus with the value of G, which means 2I plus 3J plus 2K. So the final answer is 8. And the second step, we need to find the magnitude of F and G, and then the value of F is square root 51 and then the G square root 17. And the final calculation is we need to find the angle, use the formula that I have given earlier, which means cos theta, and then the final answer we're going to get 72.36 degree. To summarize our project that we have done before, I'm going to talk about the conclusions. And when we know not only the value of a vector but also the direction in which it acts, we have a complete definitions. Vector can alternatively be thought of as numbers with a magnitude value and a direction. The scale is the only one with a magnitude value. For instance, speed, volume, temperature, and time are only a few examples. Engineers can use vectors and scalars to make it easier to design vehicles or tools that require magnitude readings. In everyday life, vectors and scalars are also used. As an example of vectors used in expanding GPS to make human mobility easier, consider the following. That's all for me. Thank you.